So this is page 26 and 27 on your big ugly packet. And I wanted to get to page 28, this week, and yesterday was not good, so we'll work on it today. So on page 26, we start with number 13, and above the number 13, it was talking about vapor pressure. And so vapor pressure is the pressure that builds up from water evaporating. So if you've got something with water in it, some of the molecules evaporate, and the more particles that are in the gaseous phase or the vapor phase builds up pressure. So that's what vapor pressure is. Why is there vapor pressure? I just explained that. So what do we do about the vapor pressure? Well, when you collect a gas over water or it bubbles through water, which it often does, then some of that water vapor is part of the total pressure in the container. So we just need to subtract off the vapor pressure. And we have tables that tell us what the vapor pressure is. In fact, there's a table there on page 26 for a few temperatures, and the one for this question is on there. So we've got some butane that we're collecting through water, and it says that it gives us the initial mass of the lighter, and then we let some gas out, and then we got the final mass of the lighter. We got the pressure of the gas, and we know the temperature. So we got the mass before is 22.24 grams, the mass at the end, 22.02 grams. Temperature is 22 degrees Celsius, which we know. Oh, what is that? So if we add 273 to 22, we get 295 Kelvin. And then the question is on 13A, use the table to find the vapor pressure. So if we're at 22 degrees Celsius, it says it's 19.83 torr. And then if we need to find, on part B, we're going to find the partial pressure of the dry butane gas. Dry means without the water, so we're going to subtract off the vapor pressure to get that. So we got the pressure, the total pressure is 755 torr. That's going to equal the pressure of the butane plus the pressure of the water, which is 19.83 torr. And we'll subtract those two numbers, and we get 735.17 torr. That is the pressure of the butane. So I'm going to put that right here. And remember, for this problems, like where we have an R, then we've got to convert the torrs to atmosphere. So we'll divide by 760. And we'll get a value of 0.96733 atmospheres. Right.
Can we come back later?
If you don't mind. Sorry, the custodian came in and was wanting to clean the room. So the volume, it tells us in the problem, was 100 milliliters, which is 0.1000 liters. We don't know the moles. We know R. And the temperature, which we calculated up there earlier. So now we just want to find out the number of moles, which would be PV over RT. And we'll plug in those things that we know. And we do the math and we come up with an answer of 0.00399 moles. Now, notice we did not round this number. Did not round the number. I think you're better off waiting till the end to round. So they'll allow you to do it either way. I think it's 3996 actually, if I haven't miscalculated. Okay, so there it is. That's the answer to letter C. Letter D, we want to calculate the mass of the butane. We knew the lighter, what it weighed before and what it weighed after. We'll just subtract those to get the mass of the butane. 24.24 grams minus 22.02 grams, and we get a difference of 0.22 grams. That's the mass of the butane. And to find the molar mass, then, we're going to take the mass in grams divided by the number of moles. And we should get something around 55 grams per mole, sorry. I rounded that to 2 sig figs because we got 2 in the 0.22. And again, if you wanted to use 0.004, you'd probably get the same answer. I'm just saying. So the percent error, we can find the molar mass of butane, which is C3H10, I believe. If I'm not mistaken, C3H10. I got, C4H10. C4H10. And the molar mass of that, when I calculated, I got 58.14 grams per mole. And to find the percent error, I'm going to take the absolute value of the difference, 58.14 minus 55, divided by 58.14, and then I'll times 100, because that's what we do. And with 2 sig figs, I get 5.4%. And that may be the end of this question. Yes, it is. That is the end of question 13. So let's do question 14. Hopefully we can get that done before we run out of space on our video. So in question 14, a sample of a pure gaseous hydrocarbon. Hydrocarbon, we don't know what it is. Hydrocarbon, which is a combination of hydrogen and carbon. So I'm going to write my formula kind of like that to begin with, X and Y being unknowns. And it says, is introduced into a previously evacuated rigid 1 liter vessel. The pressure of the gas is 0.2 atmospheres and the temperature is 127 Celsius. So we can fill in our chart here. Pressure is 0.2. Now we haven't collected this with water, so there's no vapor pressure on this one. The volume is 1 liter. And the number of moles we do not know are, we always know, and finally the temperature, it says, is 127 degrees Celsius. We'll add 273, and we get around 400. I'm going to put a decimal there to make it 3 sig figs. So now to find N is PV over RT. And we'll plug in for P, 0.2. And V is 1 liter. And R is 0.08206. And T is 400. I'm going to punch all that into my calculator. 0.006092 moles. And we probably should only have 3 sig figs since we're having an answer here. So 0.00609 moles. Letter B, we're going to calculate the pressure of the O2. Oh, letter B, O2 is introduced in the same vessel containing the hydrocarbon after the addition. The total pressure of the mixture is 1.40 atmospheres. Calculate the partial pressure of O2 in the vessel. So we know the pressure of the hydrocarbon was 0.2, and we know the pressure total when we're done is 1.4, so we just need to subtract. So the pressure of the O2 is 1.20 atmospheres. There's a little paragraph you should read. It talks about how moles and pressures are related. We talked about that earlier. If you don't remember that, we need to go back and review that. But just remember, like, as you add air particles, moles of air to your tire, the pressure goes up by the same amount. So they're directly proportional. So there's a table with some stuff on it, and it says the moles of CO2 produced over the moles of HC hydrocarbon consumed. So I'm just going to use those from the table there. The CO2 produced, I'm going to go with 0.6. And the hydrocarbon consumed, well, we'll assume it consumed it all, so that'd be 0.2. So 0.6 divided by 0.2 is a factor of 3. And for the water that was produced, water vapor, it was 0.8. And the hydrocarbon consumed was 0.2. So that gives me a factor of 4. So now it wants us to write a balanced equation. Well, it's CXHY, which we don't know what X and Y are yet, plus a certain amount of O2, which we don't know what that is yet. But it's going to make 3 moles of CO2. Wait, that's writing. And 4 of H2O. And all of this carbon here ends up here. So it's X is 3. And all of this hydrogen here ends up over here. So there's 8 there, but it's, so Y is 8. So it's C3H8 plus some O2, which we get to determine, makes 3 CO2s and 4 H2Os. Remember, there's the 4, there's the 3 that we just used. So how many O's are there for the coefficient here for the O? Well, we've got 4 right there and 6 there. So 4 plus 6 is 10. We're going to divide that by 2 because it's O2. That's a 5. So 1, 5, 3, 4 are your coefficients for your balanced equation. Calculate the mass of hydrocarbon consumed in this experiment. So we've got 0.00609 moles of hydrocarbon. And we know we can find the molar mass of C3H8 is 44.11. You can check me if you don't believe me. 44.11 grams per mole. So the moles are canceling. And we take that and we get 0.269 grams as the mass of the hydrocarbon that was consumed. So that brings us to page 28, which is where we wanted to be this week. We will probably start next week, and we need to go quickly through the rest of this packet, which is 50-some pages long. So we're 54, and we're on 28 out of 54. Well, we're ready to start 29. So we're more than halfway done, so this will go fast. We'll make it go fast. Trust me. So I will see you on Friday. Hope everything goes well. And there's other stuff to do when you're done with this. Just tell Mr. Smith you're done. So I will see you on Friday probably.